Hello, fifth grade. I hope you're having a great weekend. If it's Monday morning and you're watching this video, then I hope you had a great weekend, and I'm glad to see you back. Lesson 99 is found on page 644. The title of it is Adding and Subtracting Whole Numbers and Decimal Numbers. Like we said before, the most important part of adding and subtracting numbers with decimals is just lining up those decimal points. I guess the two objectives we're subtracting whole numbers and decimal numbers. Subtracting whole numbers and decimal numbers. So that's pretty self-explanatory. The new concept on the bottom of page 644 says, sometimes we need to add whole numbers and decimal numbers in the same problem. Read the example on the next page, 645. The Simpsons hired a carpenter to cut an opening in their wall and to install a new door. The carpenter needed to order a frame for the door to cover the thickness of the wall. The carpenter knew that the siding was 1 inch thick, that the wall stud was 3.5 inches thick, or 3 5/10 inches, and that the drywall was 0 5/10 inches thick. And then they show a picture. Hopefully you have your books, but if you don't, it's shown here that we have 1 inch, 3 5/10 inches, and then 5/10 inches here. Hopefully it's not too high or too low. But they just line it up just like this. They have 1 inch. Knowing that the decimal is assumed to be here, it's not usually written there. Again, it's kind of like a shortcut because most of our numbers don't include that decimal point, or you don't really need it for it. Then they put 3 5/10 inches, and they also have 0 5/10 inches. Remembering that if we'd like to put a 0 in here, we can. But this is basically all it is. This is the whole number that we're adding to the numbers with decimals. When you add those up, 0 plus 5 is 10. 1 plus 1 is 2, plus 3 is 5. We end up finding out that the door frame needs to be 5 0/10 inches thick. Now, when you write the number 5, you typically don't use a decimal point or this 0, so you can simplify or reduce that answer to just 5 inches thick. Understanding that when you add whole numbers without decimals, you won't always get a nice even round number. Sometimes you'll have a decimal, of course. Let's look at example 1. Looks like a lot of these examples are story problems. It says, in a science experiment, the scientist placed food at the end of a short maze and placed a mouse at the beginning of the maze. The scientist timed how long it took for the mouse to reach the food. Then the scientist repeated the experiment 3 times. The mouse's times were 6.2 seconds. We have 4.25 seconds, or exactly 3 seconds. Okay? And then it says, what was the total elapsed time of the 3 trials? So they want us to add these 3 numbers together. All right. Now again, the decimal is assumed to be just to the right of the last whole digit, the right of the ones place. So we put it there. You can plug in zeros for these numbers if you'd like to, but it's not completely necessary. Now when we add these, our place values are all represented. 0 plus 5 plus 0 is 5. 2 plus 2 is 4. Our decimal, we bring it straight down. 6 plus 4 is 10. Plus 3 is 13. Our answer is 13 and 4/45 seconds, and that is your answer for example 1. So record this on your sheets, please. All right, example number 2, found on page 646. Another story problem. It says, a computer that began a complex task 8 minutes ago needs 24 6/10 minutes altogether to complete the task. In how many minutes will the task be complete? Well, it takes it 24.6 minutes to complete the entire thing, and it's already 8 minutes into that task. So we just take the 24 6/10 total minutes minus the 8 minutes that it has already been working on this task, and we subtract it. 6 minus 0 is 6. We bring our decimal point straight down. We have to borrow. 14 minus 8 is 6. We bring our 1 straight down. So how much more time does that computer need to finish that complex task? Well, 16 6/10 minutes. All right, and example 3, the final one, it says, which digit in 4 and 65/100 is in the same place as the 2 in 12? Okay, this 2 in 12, remember that the decimal point is assumed to be right there. So this 2 in 12 is in the ones place. Well, which digit in this number, 4 and 65/100, represents the ones place? Hopefully we all know that the ones place is the 4. So your answer for example 3 is the 4. Let's do 2 practice problems. Write this one down for example number 4. Let's do practice problem. Let's just do the first one. Practice problem A says 4 and 3/10 plus 2. 4 and 3/10 plus 2. Remembering that our decimal point is assumed to be here, you can plug in a 0 to represent the tenths place as well if you'd like to. This does not change the value of the 2. 3 plus 0 is 3. Decimal point comes straight down. Our answer for example 4 that you will record on your sheets is 6 and 3/10. Example 5. We'll do a subtraction problem for example 5. We end up with 12 and 4/10. I'm doing practice problem J. 12 and 4/10, and we're subtracting 5. Again, that whole number 5, we can draw a decimal point to represent that ones place, and we can line them up like this. That's putting a 0 here is just like putting a 0 here. It doesn't affect the value of the number, but typically you don't see them over here. 4 minus 0 is 4. Our decimal comes straight down. We have to borrow from our tens place and get 12. 12 minus 5 is 7. Your answer that will be written down on example number 5 is 7 and 4/10. Again, I hope you had a great weekend, and that is all for today. I will see you Monday.